So remember to have your notes out, write down that stuff, and I'm ready whenever you are. Take it away.
Story of stratospheric ozone depletion by us. History about it, back in the 70s, scientists became weary of chemicals that could potentially be harming the stratospheric ozone layer. These chemicals were commonly found in everyday household items like aerosols, refrigerators, air conditioners. And then later in 1985, scientists finally confirmed that there was a hole that had formed in the stratospheric ozone layer over Antarctica. This kind of resulted in the Vienna Convention for the Protection of the Ozone Layer was formed and put into effect in 1988. This agreement had many groups of people putting research and discussion regarding the ozone layer depletion and kind of how to fix that, work towards.
So the chemical makeup is mainly CFS, which are chlorophoric.
CFCs.
Oh,
You said CFS.
it's
Sorry.
the dyslexic.
I know. I'm just helping.
Okay, that big word I'm not going to try and read. Were widely used in refrigerants until the 1980s when it was confirmed that they were the main source of the harm of the ozone layer. And then another main molecule in the ozone layer, whatever it's called, is ozone, which is C3.
O3.
Thank you.
You're welcome.
And that is formed when heat and sunlight cause a chemical reaction between oxidants of nitrogen and volatile organic compounds, which are also known as hydrocarbons.
Do we want to do the demonstration?
We'll do it after. Oh yeah. So the main locations of the ozone layer are obviously around the Earth, in the atmosphere, and the stratospheric ozone is mostly found in the polar regions because the ozone depleting substances mixed with the low temperatures and solar radiation is where they're mainly found. Even though they're still found throughout the Earth, they're mainly there.
Global distillation, right? Global distillation too. Yeah.
Causes and effects. CFCs are the cause, and they used to be produced by refrigerators, like aerosol spray and other components, but they are banned now, the substance, so it's not as frequent. Effects from this, an acute effect is getting a sunburn exposed for too long, and long term is immune system. You can go blind, and just the UV rays can cause cancer towards this because the sun's 10 times worse these areas.
Can you go back to the
Yeah.
We'll take a minute. I know.
I don't like presenting.
Well, while we're pausing, I mean, one thing it's great, is really good, is that remember in the beginning of the notes, when we start looking at atmospheric basics, there's 3 types of UV, A, B, and C. A always gets through the ozone layer and hits you and me and gives us a nice tan or sunburn or whatever. And you see on there they have B, but there's also UVC. They're really bad. They really do real physical damage to our skin, they said, yeah.
Is that the kind that in Florida, if you get the big pus lumps on your skin?
No,
You know what I'm talking
no, that's just from UVA. UVB and C shouldn't be getting through the ozone layer. If you're in New Zealand, those places near the Antarctic Circle where it is thinnest, where the hole is, as you just said, that's where we're finding these effects that are listed up here in wildlife and in people. Cataracts, blindness, all those things up there. It's increased there. As we'll hear, it's getting better.
Yes.
Yeah.
Are we good?
Keynotes. Point source, there is no point source. Non-point sources are refrigerators, AC,
Meaning air conditioner, right?
I was not really spelling it right. And Lysol, spray bottles.
Hairspray.
Yep.
Yeah.
The primary source of it is
Primary pollutant.
primary
Pollutant is
CFCs, and secondary pollutant is chlorine. I was talking with Alan, and this diagram shows how chlorine
demonstration later on will explain deeper how this causes the ozone to break up, and it will be more like visual for those visual.
Regulations. So the biggest regulation is the Montreal Protocol. It was made by the UN, and it's an agreement that regulates almost 100 man-made chemicals that deplete the ozone. There's this quote that basically this is what they've done in the past since 1990 to 2100. This is expected. So it's expected to avoid 443 million cases of skin cancer, 2.3 million skin cancer deaths, and more than 63 million cases of cataracts. The fund for this agreement has funded over 8,600 projects worth $3.9 billion. The main way this was done was they found a replacement for HCFCs that were depleting the ozone layer. And this diagram is their timeline, so from when it started all the way projected to 2047 in their plans.
In the future, the ozone hole will close in the next 50 years, or that's what they're expecting. The stratospheric ozone is supposed to fix itself by 2050, and with the new laws and regulations. So if the Montreal Protocol did not happen, you can see that the blue is really bad. That's with a lot of sunlight, and the world is not really in a great place. And then with the Montreal Protocol, you can tell how the ozone is mostly here and here as it should be, and it's getting back to where it used to be and better.
Oh, this was your video. Okay. My wife was
15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules per every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic in particular has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the northern hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink
So that was another example of how the CFCs break up the ozone. And then, do you have any more slides?
No.
Okay, that's our sources. So I think Alan is going to help us with the demonstration with ping pong, golf balls.
Okay, so we do a little
Nice.
demo.
Could you super quickly go back to solutions?
Yeah.
So everybody's gonna be involved in the activity.
Regulations?
Yeah.
Ask your question, Phil.
Because the substance has been
Because the solutions are more like the substances have been banned. It's not really like.
yeah, like it's already.
Since this is more of not like a country per country thing, it's more of like a whole world thing. It's more about the regulations and the
And as
substances.
you guys
that
are like, the Montreal Protocol, that sounds so cool, so neat. There is a
Year
close
three.
to 1,000-page document documenting everything the UN has done about it. No one wants it. I don't want it.
Just remember what the Montreal Protocol is.
Yeah, Montreal Protocol is the important piece here, not the Clean Air Act. But it's a treaty, so it's an agreement
And it was
with.
it's the first document that had a unanimous agreement. Like, literally
Yeah.
every single.
Like, we had, the world got behind this, and we joined together. And what's the reasons why we were able to join together? What do you think why we were able to do this treaty?
Because we're all in the same world and it's.
And they found a replacement.
Yeah, it's a real threat. Everybody saw the threat, and nobody would go blind or burn skin and cancer. Nobody wants that kind of suffering. Most of our ethical setups keep those still. Most of our ethical systems of morality don't, we don't really want another person to suffer. And so they put that in place, and then they had a reasonable solution ready to go. So that was good. So what we're going to do is a demo on how this works. So I've given a number of you some ozone. Remember, what is ozone comprised of?
Three oxygen.
Three oxygen. So stand up. And we're going to spread out like we're in the stratosphere. Let's see. Rose, come over here. You going to be CFC or you going to be photon? Photon.
I thought you were gonna be nice with that.
I lost one of my oxygen.
CFC. Riley.
Oh, yeah, photon.
Photon. You're CFC. Okay. So Nora's going to be our CFC. So please take a look. Nora's going to hold up her molecules. Notice what she has. Now, your ozone in the stratosphere. What do we know about the composition of gases in the stratosphere compared to the troposphere? They're spread out. So let's do that. Spread out a little further. Remember, if I was to take you on a field trip to the stratosphere, it'd be very difficult for you to take a breath. In fact, you couldn't. You'd have to have some sort of air supply. Just think Top Gun. Think about those high-flying Air Force pilots. They're going to be gas mass or beyond, oxygen mass or beyond. Okay, so you're spread out. Ozones are spread out. Keep your ozone molecules together. This is a photon from the sun. Riley is a photon. Rose is a photon, and we're moving through the atmosphere, moving through the stratosphere. We're getting to the ozone layer. And lo and behold, we have a new molecule floating around in here. This is Nora. She's a chlorofluorocarbon. See? The blue molecule that she has is a chlorine atom. So Rose, Riley, and I, we're going to try to hit her handle of stuff, and if we can free one of those, you get to grab the chlorine and you get to be disruptive. Yay, you get to be disruptive. See who's it? Oh, miss, your turn. Oh, that was close. Oh, that was a touch. So you get to grab one. Grab the blue. So the chlorine atom is now free. What was it? What kind of impact was that? Was that a chemical reaction?
Yeah.
It was what?
No, it's a physical.
It was a physical thing. It's not chemical. So it knocks these free. Now we have a chlorine. And so Rose is going to be disruptive. If she comes near you, she's going to break up your little party of ozone. Okay? So, who are you closest to? Yeah, so break up hers. Take one of hers away. So hold it up in the air. See, she's a chlorine atom. Hold it up, Rose. Rose, hold it up. High for the video. So you're now what? What is that when chlorine bonds with an oxygen? What do we call that? Take a guess. What would you call it? Chlorine,
Chlorine oxide. Chloroxide.
chlorine monoxide or chlorine oxide? Yep, that works. So now you're going to wander around. You're going to wander around. You're going to leave it off somewhere. Now, often I use this comparison as like a drunk at a party. She just broke up a little party. They're going off, and her good friend is trying to deal with her, the oxygen molecule. But chlorine's really disruptive. Now you're going to ditch your friend. Just drop it.
Which one? Drop the orange.
The oxygen. You don't care about the oxygen. You're
No,
chlorine. That's not the right way.
Oxygen.
Oxygen is these with the
Orange
ozone,
one.
right? Drop it. Who's the closest ozone that you have? Yeah, you can't. If it touches you, you can bond with it. But can she touch you? She's going to take yours now. Now walk around. And so chlorine atom could do this 100,000 times. That's just one chlorine atom, 100,000 times. How long does a chlorine atom or a CFC stay in the atmosphere?
Forever.
Okay, that's good. That's good. It has a residence time. Residence time is how long CFC stay in the atmosphere. 100 years. Okay, that's why it's taking so long for it to repair. Put your molecules back. I don't know if that worked or not for you, but. Oh, you can take a shot if you want. And let's ask some questions. Ask some questions. What is not clear to you about stratospheric ozone? Take a shot. Do you understand why it takes so long for ozone to repair?
Because it has to touch itself again.
Yeah, and it's spread out. It's spread out. It's less dense in the stratosphere. Okay, so what are your questions now? Do you know the primary pollutant involved in the depletion of the ozone layer? CFCs. Where are we talking about when I say the ozone layer?
Stratosphere.
Stratosphere. That ozone is good. Where is ozone bad?
In the atmosphere.
Troposphere. You and I can breathe it. Ozone's not good for us.
So we're in the troposphere, not in the atmosphere.
That's right. If we were in the stratosphere, we're in an atmosphere, but there's levels to it, right? You have to know. Please. We need to know troposphere and stratosphere on the quiz. You're going to need to know that. Troposphere is where everything happens that we're concerned about. Weather, pollutants, all that stuff. Stratosphere is where the ozone is located and we care about that. What is a secondary pollutant that is disrupting the ozone layer? Secondary pollutant. This is usually a result of something.
Chlorine.
Chlorine, says the expert. Yes. Chlorine. You should have that in your notes. Is there anything else you need clarified for this? Those of you in the audience, you know the point source? Non-point source?
There is no point source.
There is no point source. Good. It's only non-point, which made it harder to control, right? When we went to the transfer station, you remember all those appliances that piled up? They're called white goods because they're usually white color. What were most of them?
Refrigerators.
Refrigerators.
Ovens.
Because you cannot just dispose of them. They're going to extract that refrigerant out. It's not a CFC-based refrigerant, but still those refrigerants, we don't want them loose in the environment. We want to reuse them because it's easier to reuse them. So that's why you pay money for them to go. Does that make any sense? I'm not going to ask you that in the quiz. So pull things together for a final thing. Okay? Concerns about this stuff. Whenever we start talking about quiz review, we do quiz review. Here we get your presentation side. Yeah. Yeah. Yeah.
Like writing like a note for quiz. Like what is it like a term for all like the
We saw the thing on
primary pollutants?
No.
No.
When you come to it, you can clear up, okay? Give me that ping pong ball.
Alright.
It was Lewis, wasn't it?
So what are some
How much
questions?
is it?
We have a quiz on Friday.
Test corrections.
We have a quiz on Friday.
Is it timed or is it just
We also have
It's not time. It's 15 multiple choice and 5 open-ended questions.
And we get to do
You get to do corrections on it. That's why I wanted to give you a quiz instead of a big test, because I can turn around to you in time for study for the final. So we'll take a few minutes talking about what we're, about the quiz, and then I'd like us to start constructing the final, so you have more time to study for. Even though you're last, literally the last block.
When is our review for?
Great question. I have to look at the calendar.
Or no one.
Wednesday.
Alan, so I'm taking it Tuesday for the review
So
block
come to a
quiz.
different review block if you can.
Okay.
I don't know.
Do you have an E block then?
I don't. I have A and I have C. I have A and C.
Okay.
I bet you're up on Tuesday. Always.
Yeah.
Outer Banks here.
Well,
Okay.
we'll talk.
Yeah,
We'll talk.
we can plan something.
Yeah.
Quiz questions. Any other quiz worries? I will show you some sources in a moment that are for the final, but also that some of the phrasing of the questions for finals might be a good phrasing for the quiz too. Yes.
The video that we played is on our topics page, just so you know, like we got it from Al. So if you need to rewatch that video, it's on the topics page.
Also, all of these presentations are in blogs, right? Already posted, so you can study them. So remember, the end point of this assignment is you've done your slideshow. That's the narrative of your blog. That's the stuff you've already written. And there's specific things that are required on Friday. You have to have date and time of your presentation. You have your link to your slideshow, so you want to have some sort of introduction to it for the reader. And then you want to reflect and make conclusions about what you witnessed in class, about one presentation, right? Just one. You can do two. You can do three. It'd be great. But, you know, I know you got a lot of work going on. But I want you to really reflect on what you're learning. And that's what it's about, right? And writing it well. Good? Okay. Any other questions about the quiz? I'm going to turn off the recorder and show you some notes. And so I'll have those available.